Hello class. So today we come upon next topic, that is IP datagram. So as we are going towards continuation of chapter network layer protocols, we will be looking at most important topic, IPv4. And in this video we are looking at IP protocol, specifically IPv4 description, or we can say packet dissection with some examples, etc. Actually, in IP protocol, there are four different protocol existed. So first one is IP itself, and the major responsibility of this IP protocol is packetizing, forwarding, and packet delivery in the network. Three more additional protocol also exist in this layer, and these are ICMP, IGMP, and ARP. So the basic purpose of ICMP protocol is it helps internet protocol for tracking some faults during packet delivery from host to host, host to destination, source to destination, etc. Now next one is ICMP. It is only used for multicasting purpose, especially application based on multicasting like online streaming video, gamings which are executed upon LANs. So at that time we used a very important role of ICMP is still there. Now next one is ARP. It is used for mapping IP addresses to MAC and vice versa. That means from MAC to IP address itself. Basically in ARP, it is a procedure for mapping a dynamic IP address to permanent MAC address in LAN. In other terms, we can say when network layer, that means third layer of the network model, pick up anytime information from second layer, or we can say data link layer, in which MAC address is very important. So information comes from data link layer. It will be used or represent through MAC address. So whenever it transmitted from the network layer convert this MAC address to its logical address. That's why this protocol, or we can say IP protocol, as a ARP, play an important role whenever communication existed between these two layers, network to data link layer. Now we comes to the IPv4 packet explanation. First important packet info field is in IPv4, that is a basic terminology we used for packet in IP as datagram, and a datagram which is variable length and consists two major section. First one is header and another is payload, or we can say data itself. Every time header information, so it can be represented as this is header and plus data. So the header represent through this diagram here. So in this header diagram, each of row here is 1 2 3 4 5 and additional one more row is 6th row. So in each row 32 bits we used every time in this header. So total number of rows are 5, and as you know, in terms of byte, 32 bits can be converted into 4 bytes. So this is 4 bytes. So overall mandatory rows we use in header are 5. So total bytes information as in header we use 5 into 4. That means total 20 bytes of minimum header length is required in this header diagram. So that's why we use two important fields is first one is version and second one is header length. In version field we use it is used for either IPv4 or we can use it for IPv version 6. So if we use IPv4, so 4 can be it can be represented through 4 bits, so it can represent by 0 0 1 0. So and if we use IPv version 6, it can represent through 0 1 1 0. So every time if we use IPv4, the packet header with the data start with 0 1 0 0 always. And header length minimum the size of header length is 20 bytes, and it can increase if optional row is included in the IP datagram, and the size of option field is 40 byte maximum, so it can extend up to 20 to 60 bytes. Now another important field is type of service we use. Actually this field tells us about quality of service, but additionally there are some basic services on the differentiated or category of prioritization. For example, because of it represent through 8 bits, so first or we can say 0 if we use. So for in type of service, 0 stands for routine type of services. If we use 1, so 1 stands for services which are priority based. So priority based in this some type of important services like video or MPZ, or we can say text based service, which is work over lossless data compression type of services. Now 2 stand for immediate services required during delivery, so immediate. So as so on various type of services we used in this section. Now next field is total length. In total length we include header plus data we use, or the information we used in this field. So as per 16 bits representation of this field, so maximum we can use the size of this field is total length 16-bit representation of this field. So it can be represented through 2 to the power 16, or we can say 65 536. So up to 22 65 or 536 size in this field we can include it. Next important field is identification. So in identification field we use when a packet is in delivery mode in the network, the packet must be designed as where each packet distinguishably identify in the up to the destination point of view. So that means in identification field, every time source maintain a counter variable. At source a counter is maintained for this field. So suppose that counter variable is 12, that means 11th packet is successfully transmitted from the source side. Now if the counter variable is 13, that means 12th packet is also transmitted from the source side. One another important feature of this field, identification field, is if packet is being fragmented in the network anytime. So suppose that 12th packet is fragmented during transmission. So suppose the 12th packet is fragmented into 3 segments. So every time these different segments identify by 12th fragmentation ID. or packet ID itself. And these segments represent through segment ID. So ID1, ID2 and ID3 is known as segment ID, and 12th is represent as packet ID of these packet which is fragmented in the network. Next important field is flags and fragmentation. Actually, this is very important concept in the network IP datagram. So I will discuss more about with some example in the next video. So now comes to the next important field is TTL, time to live. Especially this field tells about how long any datagram is allowed to exist in the network. Basically, this can reflect a value of hops. So why we need this field actually? This is very important question sometimes asked in the interviews or exams. What is the use of TTL? So it can be understand by one example, like suppose this is the scenario for packet transmission from source to destination, and a situation of packet transmission we deal it here. So in a network, suppose source transmit packet 1 and the definite route as A, B, C, D, and suppose after that it can be transmitted to this. So the definite route is this. Through this way packet should be transmitted, but due to some network or due to some corrupt information occur during transmission, packet is which is passed through this way but still getting some corrupt in own header, it get through this way. So suppose that this is the node D dash, and through this procedure a packet is going into the loop, or we can say the packet is stuck in this loop. So this is the problem of looping in LAN or WAN, we can say. So to avoid this situation, we use the concept of TTL. So how TTL avoid this situation? A source will use a value like 20 for TTL. So if TTL value is 20 and it transmitted the packet 1 and used for packet 1, now packet if transmitted at A and transmitted through B, so it will change to 19, and if it reach at B it will change to 18. If it reach at C it will change to 17. If at D it will change to 16, and now it will finally reach at destination point. So within this TTL value, if packet arrive at destination, so there is no any problem during this transmission. But if packet go into this situation of looping somewhere due to some noise or corrupt information in header, every time after 17 value at D dash is 16. Now again at B it will be changed by 15, and if at C it will be changed by 14, and so on. Whenever this value reach at 0, the packet discard by own self by that particular node. So in this way the looping problem can be avoided, because of actually the looping is a more worse problem in the network, because of if looping is occur in somewhere, the network assume that a traffic congestion is still occur in that position. So if congestion is the network, that means every time source and destination sense this network, and that sense that there is some congestion or there is some jams in the network, that's why they are not efficiently transmit another packet from the source to destination. So the next field is protocol. So the next packet is protocols. As we discussed in start of this video, a basic protocol of IP layer used as ICMP ICMP, ARP, OSPF, and so on. These protocols for data link layer communication. And now if the network layer communicate from the transport layer, which is higher than the network layer, then network layer use the protocol TCP and UDP. So it is the information used in this field protocol which and tell us about protocol information which is carried with IP datagram. So whenever ICMP is used as a services in this protocol, ICMP use the value 01, ICMP use 02, OSPF sometimes use 89, and TCP use 06, and UDP use 17. So as so on various type of protocols, whenever we used in this value, we look out this value, and we can conclude that this type of services used with this IP datagram. Now the next field is checksum. Now in checksum, which is the important field in used in the network layer, and as contrast to the data link layer, where data link layer it will be used as a 32-byte checksum or 8-bit checksum also. But in network layer, checksum only is used for 16-bit checksum we can use, and the 16-bit checksum we used for checking of header information, not for the data diagram. So how checksum can be applied? It will be understand through example. An example is 8-bit checksum we used here. So the procedure of checksum can be applied as, so suppose that all 8 bits data or header information we use, suppose that in this example, so all this information, so in a step first we add all these to each other. So after applying this addition, we get the result as 1 0 1 itself 1 0 0 0 1 0 1 0 0. So we can say actually we'll get this value. So this is 10 bits information basically. This is 5 bits and this is also 5 bits. So this can be 10 bits. So additional 2 bits if we receive in the result, we add it on this. So 1 0. So we add this, and now finally we get the result is 1 0 1 0 0 0 1 0. So this is the final result after getting addition of this header information. Now take in step 2 we complement of this result, so we will get the value 1 1 0 1 1 0 1 0. So this is the checksum value, and we transmit it to the network, and after receiving by the receiver applied this checksum with this information and with same procedure, and check that the header information is correct or not. If not, so it will be discarded by receiver and request to the node for retransmission. So in this way we can understand that the IP datagram easily, or I hope that it might be helpful for your examination purpose. The last two field is source IP address and destination IP addresses we can use in this datagram, and it I actually in last videos I deal with this source IP addresses addressing schemes in the last some videos. So in the next video we will meet with the concept of fragmentation and flags information, actually about these two fields, and some examples we will discuss this concept. Thank you.